Hello and welcome again to our mathematics lesson. We are continuing to look at the topic on indices and surds. In our last lesson, we were able to cover an aspect concerning the two laws of division and multiplication, where if you can be able to recall, we said that for the multiplication law of indices, when we have a raised to m multiplied by a raised to n, then given that the bases or the factors are the same, then we are going to add the powers. So the resultant will be a raised to m plus n. For the division law of indices, we said that if you have a raised to m divided by a raised to n, then given that the bases are the same or the factors are the same, then this shall be a raised to the difference of the powers, meaning this shall be m minus n. So just to perform one example that requires you to apply both, if you have 7 raised to 3 multiplied by 7 raised to 7, then that means we are going to apply the multiplication law where we are going to add the powers, and this shall give us 7 raised to 3 plus 7, which will give us 7 raised to the power of 10. Then if it was division where we have 7 raised to the power of 7 divided by 7 raised to the power of 3, then given that these bases are the same, then the results we are going to subtract or get the difference of the powers, that is 7 minus 3, which will have given us 7 raised to the power of 4. So that was it. Today we want to look at the zero index and the power of another power. What happens when you are given or such cases or such scenarios? First, let us try to consider a case where we have a power of another power. And in this case, we have 2 raised to the power of 3, again raised to the power of 4. In this particular case, you can be able to see that yes, 2 is a power by itself. It has been raised to the power of 3. Then the whole of it again has been raised to another power, which is the power of 4. We can have a raised to the power of 2, again raised to the power of 5. So in this case, we say that a power has been raised to another power. So consider a case where we have a raised to m, then the whole of it again is raised to n. So if we write this in the expanded form, you first begin by m factors of a, again you multiply by the n factors of a, and this will give us m factors of a shall be a times a times a. There are so many times another a. So those are the factors of m. Then, m factors of a. Then we have got n factors of a, which in this case we can have it as A multiplied by A multiplied by A multiplied by A. Again, also there are so many. So when we raise this to this, that means we are going to multiply this one and this one together, and when combined, this is going to give us the m factors of A, which is A times A times A times there are so many times A, again multiplied by the n factors of A, which shall be A times A times A times A, there are so many, times another A. These are m factors of A. These are the n factors of A. So this will automatically follows that we are multiplying the factors of m factors of A and the n factors of A, which will result or will give us A raised to m multiplied by n, which is simply A raised to mn. So that is what happens when you raise a power over or to another power. So we multiply the powers together. Then for the case of this zero index, consider a case where you have A raised to m divided by A raised to m divided by A raised to m. This will mean that we have m factors of A being divided by m factors of A. So given that the m factors of A, there are so many, we divide them by again the m factors of A times A times A. Again, there are so many. These are the m factors of A. Also, these are the m factors of A. So whenever you do that, you'll find that all these will cancel out, which will simply give you 1 over 1, which when simplified, this will give you a total of 1. But you can also be able to recall that when we use the law of indices during division, this is m raised to m subtract m, which will give us A raised to 0. So this will tell us that whenever we have A raised to 0, the result will always be equal to 1. And this is our zero index. So whenever you raise any number to the power of 0, that number results or becomes 1. So we now have the two. We have said 1 for the zero index. A raised to the power of 0 will be 1. So if you have 20 raised to 0 will be equal to 5 raised to 0 will be equal to 4 raised to 0 will be equal to any number raised to 0, which will always give us 1. Then number 2, we are saying that if you have A raised to the power of m, again this one raised to n, the result will be m raised to m times n, which will be equal to m raised to, if we have m raised to m, then the whole of it raised to n, this shall give us A raised to m multiplied by n, which will result to A raised to mn. So for the power raised to another power, we multiply, or we get the product of the two powers. Then we have said any number raised to the power of 0, that number becomes 1, not 0. So here we can be able to say that any term except the 0 itself when raised to 0, the result is 1. And then for this other case, we have said whenever you raise a power by another power, then the resultant, we get the product of that particular power. Let us consider a number of examples on how we can be able to solve these two scenarios. Example 1. We are told that simplify each of the following. Number 1, we have x raised to 5. The whole of it is raised to 4. Number B, 3y raised to 5. The whole of it raised to 2. Now, in the solution for these two particular cases or examples, we are having a power raised to another power. And we'd say that whenever a power like raised to m is raised to another power n, the resultant will be to multiply the powers together. So that means that for this case, this shall be, we shall have our factor x multiplied or raised to 5 times 4, which in this case shall give us 5 raised to 20, where now 20 is our new power. For this case, 3 is not affected by either of the power, so it is outside. Then we are having y raised to 5, again raised to 2. So that means we are going to have y raised to 5 times 2, which shall give us 3y raised to the power of 10. Example 2, where we have the case of a 0 index. Apply the 0 index rule to evaluate the following. 1, we have negative 3 raised to 0. B, minus 5x raised to 0. Then C, 2y raised to 0 minus 3y, the whole of that raised to 0. Now you can be able to recall that whenever we have the 0 index, any number a raised to 0, the resultant is 1. So for this first case, we are having a number that has been raised to the 0 index. Therefore, the whole of this number will end up becoming 1. For this case, we have a negative outside. Then we have got 5x, the whole of it being raised to the power of 0. So this means we're going to have negative into 5 raised to 0, x also raised to 0 when you filter in the power 0. So this will give us the negative of 5 raised to 0 is 1, x raised to 0 is 1. So this will give us negative 1. Then finally, you have 2y raised to 0, subtract 3y, the whole of it raised to 0. Now in this case, 2 is not affected. 2 is outside, then y has been raised to 0, then the whole of it now has been raised to 0. So in this case, y raised to 0 will be 1. So this will be 2 multiplied by 1. Subtract the whole of this will be 3 raised to 0, y raised to 0. So all of it will go to 1. So this will give us 2 less 1, which is simply 1. So these are the resultant for the first one, the second one, and the third one. So note that whenever you raise any number to 0, that number automatically becomes 1. Let us look at a case where we have a combination of the 0 indexes and a power of another power. Apply or simplify each of the following. By applying the various indices law. Number 1, we have x raised to the power of 2. The whole of it has been raised to the power of 3, then multiplied by x raised to the power of 3, the whole of it raised to the power of 5. Part B, we have m cubed, the whole of it raised to the power of 4, over m raised to the power of 7. We shall be able to write the other one. Number C, 4x squared times 3x cubed, all of this divided by 6x raised to the power of 5. So these are 3 cases that have combined multiplication, division, raising to a power, and I don't know if you're going to get some powers of 0. Now in this first case, in its solution, we need to solve these 2 parts independently. You realize that the first part, we are having a power of another power. Whenever we have a power of another power, that means we're going to multiply the powers. So for this case, x shall be raised to 2 multiplied by 3, multiplied by x. On this again case, we multiply 3 by 5. So this shall give us x raised to the power of 6 multiplied by x raised to the power of 15. So again, when we now combine that, we are going to use the multiplication law, where we are going to add the powers because the bases or the factors are the same. So this shall be x raised to 6 plus 15, which will give us x raised to 21. For part B, we have m raised to 3 raised to 4. So that means for the numerator, we are going to multiply the powers over m raised to 7. So when we simplify, for part B, we have m raised to 3, again raised to 4. So this means we're going to apply the law of a power over power, where we're going to multiply the powers 3 times 4 over m raised to 7. So this shall be m raised to 7, that is 3 multiplied by 4, you get 12. M raised to 7 is that. Then we now use the division law, where we have a common factor m, and for the division law, we are going to subtract the power. So this will be 12 minus 7, which is going to give us 5. So this is m raised to 5. For our last case, the numerator requires us to use the multiplication law, where we have 4x squared times 3x cubed. 4 by 3 will give us 12. Then for the x's, their powers are going to be added because we are multiplying. So 2 plus 3 will give us 5 over 6x raised to 5. So this will give us 2 there, 6 there, 1, 6 there twice. So this shall be 2x raised to 5, subtract 5 because of division. So this will be 2x raised to power 0. But we all recall that any number raised to the power of 0 under the 0 index becomes 1. So this shall be 2 multiplied by 1, which will give us 2. Example 4. Simplify each of the following. And you leave your answer in index form. Number 1, y raised to 6, the whole of it squared. Number B, m raised to 3, the whole of it raised to 6. Then C, 2 multiplied by negative j, this is j, j raised to negative 4, again the whole of it being raised to 6. So in solving this first case, this is a power of another power, and if it's a power of another power, that means you're going to multiply the powers, and this will result to 6 raised to 6 times 2, which shall be y raised to 12, just as simple as that. The same with this, it's a power of another power, so this shall be m raised to 3 times 6, which shall be m raised to 18. Then for this other case, 2 is outside, so we are having j raised to negative 4 by 6. That will be 4 by 6, which will give us 2 into j raised to negative 24, because when you take a negative integer, you multiply by a negative integer, the result is negative. So this will be 2j raised to negative 24. Let's look at a case of combined law. Simplify by combining. Simplify by combining various index laws. Number 1, we have 4 by 4 raised to 2. Part B, a squared multiplied by 3 multiplied by a raised to 4. Number C, s cubed raised to 2 times 5 r raised to 0 multiplied by 3 times rs squared. So we want to combine the different laws of indices to be able to solve these 3 questions. So for the first question here, this is like 4 raised to 1. So let us begin by dealing with this power of another power. So we say that whenever we have a power of another power, that means we are going to multiply the powers together. So this shall be 4 raised to power 1 multiplied by 4 raised to the product of the powers, which is 3 times 2, which shall be 4 raised to 1 times 4 raised to 6. Then the other law for multiplication comes in, where whenever we have equal bases or factors, then for you to be able to get the resulting power, then we are going to add the power. So this shall be 4 raised to 1 plus 6, which will be 4 raised to power 7. Next, we have a raised to 2 raised to 3 times a raised to 4. So again, we deal with this where we have a power of another power. So during this case, we're going to multiply this power so that we get a raised to 2 by 3 is 6 multiplied by a raised to 4. We now bring in the multiplication law, where because the bases are the same, we are simply going to add the powers, and this will give us a to the 6 added to 4, which will be a raised to 10. And then for this final example, we are having s cubed raised to 2 multiplied by 5 into r raised to 0, r raised to 3 multiplied by r s squared. So beginning with the first one, this is a power of another power, so we're going to multiply the powers, and this will give us s raised to 3 multiplied by 2 is 6 multiplied by, we have 5 r raised to. Now this is 0 times 3, which will give us a 0, because a 0 multiplied by any number will be 0. Then multiplied by rs squared. Then this will give us s raised to 6 multiplied by s multiplied by r raised to 0. We had said that any number raised to power 0 is 1. So that will be s multiplied by rs squared. So we have s, and s squared. We are going to combine them using the law of multiplication. And this shall be s raised to 6 plus 1 plus 2 multiplied by r, which shall give us s raised to 6 plus 1 is 7, 7 plus 2 is 9. Then r is raised to 1. Example 6, still on simplification. Simplify each of the following. Number 1, we are having 3x raised to power 4 times 6x raised to power 3. All of this divided by 9x raised to power 12. Now for us to be able to solve this, we are going to majorly use the multiplication and the division laws. So in solving the numerator, we have 3 by 6, which will give us 18. Then x raised to 4, x raised to 3. Because of multiplication, we are going to add the powers. Therefore, 4 plus 3 will give us 7. We divide by 9, x raised to 12. So 9 there once, 9 will go into 18 twice, so we shall have 2. Then because of subdivision, we are going to subtract. So we are dividing x raised to power 7 by x raised to power 12. So this shall be 7 subtract 12, which will give us 2x raised to power negative 5. So that is it. So you first begin by working out the numerator before you combine with the denominator, then go ahead to use the division law or rule. Part B, we have 5x raised to 5 times 4x raised to 2 all over 2x raised to 10. So again, for this case, we first work out the numerator before combining it with the denominator. Now for the numerator, we have 5 by 4, which will give us 20. Then we are multiplying, the bases are the same. It is raised to 5 raised to 2. That means we add the powers. 5 plus 2 will give us 7 over, we now combine 2x raised to 10. 2 will go there once, 2 will go into 20 10 times. So this shall be 10 x. Then because of the division, we'll use the division rule, where we now take 7 subtract 10. This will leave us with 10x raised to 7 minus 10 is negative 3. Notice that whenever you are subtracting a bigger value from a smaller value, the result will always be negative. Number C, (24) x raised to 4, again raised to 4, divided by 8 into x raised to 4, the whole of it raised to 2. So for us to be able to solve this, we first begin by working out this section where we are having 4 raised to the power 4. Because it's a power over another power, then we are going to multiply the powers. So that shall be 4 by 4, which will give us 16. So in the numerator, we're going to have 24 x raised to the power of 16 divided by, on the numerator, we have 8 x raised to 4 raised to 2. That means again we're going to multiply the powers. 4 by 2 is 8. So this shall be 8, x raised to the power of 8. Now 8 goes into 8 once, 8 goes into 24 3 times. So this is going to give us 3 raised to, 3x raised to. Now because we now have division, we are going to use the division law, which says that whenever we have division, we are going to subtract the powers. So this will be 16 less 8, and this will give us 3x raised to 8. 16 minus 8, you get 8. So always recall how those laws are used and how they are applied. Part D, we have 4 d raised to 4, the whole of it raised to 3, times e raised to 4, the whole of it raised to 2, divided by 8 into d raised to 2, the whole of it raised to 5, times e raised to 7. So again, this is another similar example, but we are now having different pronumerals on the same equation. For us to be able to solve this, we need to evaluate what we have for the factor of d and the factor of e. Again, these are power of another power. We are going to multiply the powers. 4 by 3 will be 12. So this will give us 4d raised to the power of 12 multiplied by e raised to 4, the whole of it raised to 2. That shall be 4 by 2, which is 8, divided by, this is 8, multiplied by, again this is d raised to 2 raised to 5. So we're going to multiply the powers to give us 2 by 5, which is 10, then times e raised to 7. So this will give us 4 over 8, and we are having two factors, d and e, being divided. So d raised to 12 subtract d raised to 10, we are going to subtract the powers, so 12 minus 10. E raised to 8 divided by e raised to 7, that will be 8 minus 7, which will result to a half d raised to 2 e raised to 1. That will be the overall result for that question, which can also simplify to be d squared e all over 2. Part E, we have 6 m cubed raised to 2 n raised to 5 raised to 3, the whole of it divided by 15 into m raised to 5, the whole of it raised to 0, n raised to 2, the whole of it raised to 7. So you can easily try to work out that one very fast. We are having m and n as the factors in the numerator. We can begin by solving them. Because we are having a power of another power, we are going to multiply the powers. So this shall be m raised to 3 by 2, which is 6, n raised to 5 by 3, which is 15, all over, we have 15 in the numerator, m raised to 5 by 0, you get 0, then n 2 by 7, you get 14. Now we had said that any number raised to 0 will automatically be 0. So this shall be 6, m raised to 6, n raised to 15 over. Any number raised to 0 is 1. So this shall be 15. 15 multiplied by 1, or any number multiplied by 1 remains the same. So in the denominator, we're going to have 15n raised to 14. And that tells you that we are only going to divide n raised to 15 by n raised to 14. So this will give us 6m raised to 6n raised to 15 all over 15n raised to 14. Then we now apply the division law or the division rule. That shall be 6 over 15 m raised to 6 n raised to 15 subtract 14. This 6 over 15 will give us 2/5, so this will be 2 over 5 m raised to 6 n raised to 1. And when you simplify, this will be 2 m raised to 6 n all over 5. The last question on this part, that is part F, we have 2 a cubed raised to 4 b squared raised to the power of 6 all over 16 a raised to the power of 0 b raised to 6 again raised to 2. So we're going to make use of several laws. The first one is the power of a power, which is going to affect a and b, also a and b. So in this case, 2 is not affected, so we shall have 2 a raised to, because this is a power of the other power, we're going to multiply the powers. 3 by 4 is 12. B raised to 2 multiplied by 6 will give us 12 all over. A raised to 0, we had said that any number raised to power 0 is 0. So we are going to have 16 is 1. Any number raised to 0 is 1. And therefore a raised to 0 is going to be 1. Therefore we're going to have 16 multiplied by 1, b raised to 6 by 2, which is 12. So when you simplify this, we are going to have 2 over 16 multiplied by a raised to 12, b raised to 12, subtract 12 because we are having b raised to 12 divided by b raised to 12. So this one simplified, 2 there 1, 2 there 8. This will give us an eighth of a raised to 12, b raised to 0. Again, we understand that any number raised to 0 is 1. So that means we are going to have an eighth a raised to 12, which you can also be able to simplify and say it is a raised to 12, all these divided by 8. Want to look at worded examples. We are told that there are 100 rabbits. On Mr. Barrow. At the start of the year 2000. The rule for the number of rabbits n after t years from the start is n, where n is the number, is equals to 100 multiplied by 2 raised to t, where t is the number. Question number 1, find the number of rabbits at 1, t is equals to 2, 2, t is equals to 6, and 3, t is equals to 0. So we have 100 rabbits on the farm of Mr. Barrow at the start of the year 2000. We have a rule of the increase of the rabbits in over the given number of years t, which the rule states that n is equals to 100 multiplied by 2 raised to n, where n is the number of rabbits at a given time period t. So when time is 2 and you want to get the number of rabbits, we simply replace in the formula or in the rule where there is t with 2. So this shall be 100 multiplied by 2 raised to 2. 2 raised to 2 is 4, and this will give us that n shall be 100 multiplied by 4, which will be 400. So there will be 400 rabbits at the end of the second year. At the end of the 6th year, n again uses the same rule, but now t is 6. So where there is t, we replace with 6. This will give us that n is equals to 100 multiplied by, when you take 2, you raise to 6, you'll get 64. And therefore 64 multiplied by 100, you will get 6,400. So there are 6,400 rabbits at the end of the 6th year period. What if when time is 0? Again, the rule applies. N is equals to 100 times 2 raised to t. In this case, t is raised to 0. We understand that whenever you raise a number to 0, it will be 1. And this will give us that n shall be equal to 100 multiplied by 1, which shall be equal to 100 rabbits. That means at the start of the year 2000, when time is 0, the number of rabbits in the farm were 100. Part B. Find the number of rabbits at the beginning of one, the year 2003, and 2, the year 2007, and 3, the year 2010. So at the beginning of the year 2002, we understand that this business began at the start of 2000. So by the end of 2000, that was 1 year. End of 2002, that is 1 year. Then beginning of 2003, we will have only spent 2 years, and therefore T will be 2. The same with this. You can take 2007, you subtract 2000, then you less 1. So T is going to be 7 minus 1, which is 6 years. Same with this, 10 subtract 1, here T is going to be 9 years. So here T, we have said, is equals to 2 years. T is equals to 6 years. T is equals to 9 years. You take n subtract 1. So we now recall our formula. N is equals to 100 times 2 raised to t, where t is the number of years. Now when the number of t is 2, then we are going to have 100 times 4, which is again going to give us 400 rabbits. For the second, at the beginning of the year 2007, n again shall be equal to 1000 times 2 raised to the number of years, which is 6, which will give us 100 times 2 raised to 6 is 64, which will give us 6,400 rabbits. Then for the final one, when n is 9, this shall be 100 times 2 raised to 9. 2 raised to the power of 9 is 512, so this will be 100 times 512, which will give us 51,200 rabbits. So at the beginning of the year 2010, at the Barrows farm, we shall be having 51,200 rabbits. Finally, part C. We are told how many years? How many years will it take the population? Will it take the population to first rise to 500,000 rabbits? Now we are going to still use our rule where we say that the number will be equivalent to 100 times 2 raised to the number t. And when you make the necessary replacement, we want the number to be 500,000 rabbits. So where there is n, you replace with 500,000. Then we can now divide through by 100 to eliminate that, so that we have 2 raised to t to be equal to 5,000. From there, we make the introduction of logarithm. So this will be the log of 2t is equals to the log of 5,000. Whatever you do to the left hand side, you also do it to the right hand side. So when you apply the law of logs, this is the same as t log of 2 is equals to the log of 5,000. So when you want to get the value of t, we'll have to divide both sides by log 2 all over log 2. That means that t will be equal to the log of 5,000 When you want to get the value of t, we'll have to divide both sides by log of 2, and therefore t will be equal to the log of 5,000 all over the log of 2, which will give us t to be 12.288. This, when wrapped up, this should go up to the 13th year. So we require 13 years for us to have at least 500,000 rabbits at the farm of Mr. Barrow. So to wrap up, let me give you an assignment which we'll try to work it out. Number 1, if m and n are positive integers, in how many ways can a raised to m raised to n is equals to a raised to 16 be expressed? To evaluate 1, 10 raised to 3, all of this raised to 7, divided by 10 raised to 18, and b, 5 raised to 2 raised to 3, all over 8 raised to 4 raised to 7 times 8 raised to 7 raised to 4 over 5 raised to 3 raised to 2. So try working out this one, of course using the different laws that we have been able to learn during this particular 2 lessons. So today we have been able to look at the zero index and the power over power, where we said that whenever you have any number raised to 0, that number will be 1. And it can be any number. 5 raised to 0 is 1. 1 million raised to 0 is 1. Any number raised to 0 is 1. Then 2, we have talked about a power of another power. So that when you have a raised to m, again raised to n, this we multiply the powers, and this will give us a raised to m times n, which will be a raised to mn. A good example, if you have 2 raised to 5, again raised to 3, this will give us 2 raised to 5 by 3, which will give us 2 raised to the power of 15. So that is it all for today. The next time we meet, we shall be able to look at the extension of the index laws and how they are applied. Thank you.